and welcome to this short introduction to the statistical tools of the GDI. In this episode we're going to have a quick look through the different ways we can use statistics together with the GDI. Firstly, I'm going to show how we can create some basic descriptive statistics for different plots. Then I would like to show you how we can make use of visual statistics and put some of these basic principles in practice and display some summary statistics on our plots together with the data. Then I want to show a couple of advanced features that come with the latest GDI. These include the percentile plots and also principal component analysis. So firstly, I want to show you that we can create a set of basic descriptive statistics for a given set of data in the GDI. This creates a summary table of descriptive statistics such as the min, max, the range, the median, the standard deviation, and the variance. The statistics report follows the active data on the plot, so you can toggle items on and off and update your table, and this is now also available in all windows. When it comes to creating some visual statistics, we can add a number of different items onto our plots to give some visual description of the statistics that we can have for our data. So in a histogram window we can create a cumulative distribution function which shows the different percentiles of the data, and we can also produce a box plot which again is based on the descriptive statistics and the percentiles. In the crossplot window we can also show a bag plot, which is essentially a 2D box plot covering two axes of data. Finally, in the new GDI we can also create two more advanced views to the data using some more advanced statistics. The first is the percentile plots, where we show the data as a score between the distribution functions of each of the axes, and this can be useful to show how the distributions of the two data sets compare. Finally, we can also show a principal component analysis of our two axes, and this can be useful to bring out strong patterns in a kind of cloud of data, and this works by basically it draws the two strongest directions of influence in your set of data. So it can be useful to establish a trend from many variables or a large population of data. So let's take a look in PERCENTILE at how this works. So first of all, what I want to do is to show you some of the basic descriptive statistics we had, and to do that I just want to open up a matrix window here for a simple set of wells. So the descriptive statistics are really easy to produce. We can simply find the button here on the main toolbar which says toggle statistics, and when we do that in a matrix window we basically get a table here with a tab for each of the different dimensions. So first we see porosity, then permeability, and then gamma ray. So you can see here that this is a set of descriptive statistics. We have the min and the max, the delta, which is the range, and then our mean, standard deviation, our variance, and then our basic percentiles of the data. What we can also see is that this table of statistics follows the data as you play around with it in GDI. So if we were to, for example, color the wells here by children, then we would get those two separate wells as part of the table, or if we colored by our fluvial facies, then we get a table for each of the different facies. I also want to show we can do the same from a crossplot window, where we can again toggle our statistics for the two different wells. And here it also can be useful to use the split by function, so we can split by fluvial facies, for example, and this will split our both our crossplots and our statistics into a group for each facies here. And again, if I start to toggle off some of the other facies. I can create, for example, a really nice description here of these two facies and get a summary of the statistics for each of those facies as well. So it's just a quick example of how we can use the statistics together with the plot to get a very nice summary. I now want to move on and show you some of the visual statistics that we can produce with the GDI. And to firstly do that, I'm going to open up a simple histogram window, like so. So here we have just a simple 1D histogram for porosity, and the most basic function that we have is our cumulative distribution function, which is just a visual representation of the percentiles of the data. We can, if we want to, also adjust the given percentiles we want to show, and again it follows the data that you have. So if we color by facies, then we can get a distribution function for the different facies in our well data here. Then I would like to show you that we can also draw the box plot for the data. So if we click on this drop down here, we can choose to draw the data, and we can also draw statistics. So if I just switch back to data and draw statistics, here we can see that we can get a box plot representation of this data. So a box plot is basically defined by the min and the max of the data, the P10 and the P90, and the mean, which give you a box. Then I would like to show you how we can also display it in a crossplot. So here I can create a crossplot window, and if I then choose to draw the statistics, I get now a what's called a bag plot for the for this VP versus VS here. So here we have kind of the same description as a box plot. We have the outer line, the dashed line. This is the range of the data defined by its min and max. The solid line is the P10 to the P90 of the data, and the crosshair here is the median of the data. So there we can just see that we can, of course, use this data to create a quick visual representation of the statistics. If I was to also display this in a histogram, I can also split this into a multi-dimension histogram, where I might want to have, for example, VP, VS, and row. And then together with the statistics here, I can basically see where I may have overlaps in different axes here between the different dimensions. Finally, I want to show two of the more advanced statistical analysis techniques that we've added to the new GDI. The first of all is access similar to the draw statistics here, is the draw PP plot or percentile plot. And what that does is it basically plots the two different cumulative distribution functions for each of your dimensions against each other. And if you have two distribution functions that are equal, then you'll get a straight line. So a straight line here is given as a guideline. And what we can see then that the range of these two cumulative distribution functions are fairly similar, since the data plots along this line here. If I was to change one of the axes here, we might see that we get a less good fit with the straight line, meaning that the two distribution functions may be quite different. And again, by using GDI and combining windows together, we can of course investigate easily different trends in our data. So here we can compare the percentiles with the 1D distributions in the histogram window. Finally, when working with a lot of data points, it can be difficult to extract some trends from your data, and that's where techniques like the principal component analysis come in. So here we can just toggle the principal components and maybe turn off the raw data. And what this does is it'll summarize the data by the two strongest axes of variance in that particular data set. So here we can see that we have one strong axis this way and one slightly less strong axis of variance moving in the other direction. So this basically lets you capture the strength of the variance in a particular data set. For those of you familiar with principal components, we also get our eigenvectors here in a table of statistics below. So that concludes this introduction into some of the statistical tools in the GDI, and we hope that you find it useful. Thanks.